Hey everyone, and welcome to This Explainer. Today, we are absolutely tearing down the illusion of magic to explore, honestly, the greatest conceptual machine humanity has ever built. I'm talking about the modern scientific method. You know, for centuries, our understanding of the world was basically built on inherited authority, dusty old books, and let's be real, a whole lot of guesswork. But between the 16th and 17th centuries, all of that completely changed. We built a framework that totally redefined the very nature of knowledge itself.
Seriously, think about it for a second. How did humanity go from believing the stars were literally magic to knowing exactly how the universe works? Imagine living in a world where the rules of nature felt entirely arbitrary, like they were driven by mystical forces or just unquestionable ancient texts. And then, in a relatively short period of time, we transition into a world governed by predictable, observable mechanics. Like, how did we make that monumental leap from relying on theology to relying on controlled observation?
Well, here is our roadmap for today to figure that out. We'll start with 1, the experimental revolution. Then 2, Galileo's mathematical reality. 3, Newton's universal laws. 4, the clockwork universe. And finally, 5, the infrastructure of truth.
Let's just dive right in with Section 1, the experimental revolution.
Okay, so picture the 16th century. Expanding global trade and the recovery of classical texts basically proved that the ancient descriptions of the world were, well, often completely wrong. Humanity desperately needed a new method for figuring out what was actually true. We had to abandon what we call Aristotelian dogma. That was the old way, relying on inherited authority and just kind of guessing based on spontaneous observation. We had to shift to modern science, and this meant systematically testing ideas. It meant deliberately manipulating phenomena in controlled experiments to reveal the hidden relationships that actually govern our reality.
And that brings us to a massively foundational concept, reproducibility. The philosopher Francis Bacon argued that knowledge had to be built from inductive reasoning and hard data, but it was Robert Boyle who really took it to the next level. Boyle basically said, look, an experiment is not some private revelation you have down in your basement. It's a public performance. If you drop a feather in a vacuum chamber, like Boyle and Robert Hooke did with their crazy air pump, it only counts as a truth if someone else can build that exact same bizarre contraption and get the exact same result.
Moving right along to Section 2, Galileo's mathematical reality. Now, if Francis Bacon provided the philosophy for this new experimental method, Galileo Galilei provided the practical, disciplined procedure. He took empirical inquiry and turned it into a rigorously quantitative enterprise. He famously said, and I absolutely love this quote, "The book of nature is written in the language of mathematics." Before Galileo, scholars mostly looked for qualitative vibes, essentially just descriptions of how things felt or looked. But Galileo totally changed the game. He demanded hard, quantifiable, mathematical patterns. So how did he actually prove this? Well, Aristotelian dogma told everyone that heavy objects fall faster than light ones. Makes intuitive sense, right? But Galileo challenged this, and not just with logic, but by building a physical experiment. He built these long, smooth, inclined planes and rolled bronze balls down them. By doing this, he effectively slowed down gravitational acceleration just enough so he could actually measure it using a water clock. He revealed that the distance covered increases with the square of the time elapsed. Boom! He proved that all bodies fall at the exact same rate regardless of mass, literally shattering centuries of unquestioned dogma with pure, undeniable math. Which takes us to Section 3, Newton's universal laws. By the late 17th century, science was kind of heavily fragmented. Earth had one set of rules, and the heavens had a completely different set. We desperately needed a grand unification. But just look at how incredibly fast this scientific revolution unified these ideas. In 1609, Galileo is just looking at the phases of Venus and shattering the idea of perfect celestial spheres. By 1660, scientists are organizing into formal groups like the Royal Society. And then, just a few decades later, in 1687, Isaac Newton publishes the Principia Mathematica. I mean, in less than 80 years, these radical ideas built upon each other at absolute breakneck speed. In that 1687 publication, Newton introduced something that changed human perspective forever: universal gravitation. He proposed that every mass in the universe attracts every other mass. And the absolute brilliance here is that word, universal. Newton's framework completely erased the ancient boundary between the celestial and the terrestrial worlds.
The exact same invisible force pulling an apple from a tree to the ground is the exact same force keeping the moon in orbit around the Earth. Nature, it turned out, played by one single rulebook.
And Newton's technical brilliance? It honestly cannot be overstated. He didn't just give us the law of universal gravitation and the three laws of motion. He literally had to invent a completely new mathematical language, calculus, just to analyze continuous change, because without it, his universal laws would have just been rough approximations. Oh, and he also proved that white light is a spectrum of colors, using a prism, just for good measure. These universal mathematical rules didn't just sit around in some dusty textbook. They literally formed the foundation for the engineering that would shortly drive the Industrial Revolution.
Which brings us right into Section 4, the clockwork universe. With Galileo's math and Newton's laws, the achievements of the scientific revolution finally coalesced into an entirely new way of seeing reality. Nature was no longer this mysterious, living organism with its own inherent, magical purposes. It was a machine. Through a concept called reductionism, thinkers like René Descartes argued that just as you can understand a pocket watch by examining its little gears, you can understand the entire universe by analyzing its simplest parts. And this clockwork mindset reached way beyond physics. It gave humanity the ultimate confidence. Think about it. If the universe is a machine operating on discoverable laws, then human ingenuity can harness those laws. This fostered the design of steam engines and factories. It influenced Enlightenment theories of governance, where political thinkers started believing that society itself could be repaired and optimized through rational principles. It also birthed the concept of determinism. That's the idea that if you knew the position and velocity of every single particle in the universe, you could mathematically predict every future event. Wild, right? Finally, let's look at Section 5, the infrastructure of truths. Because great ideas need a home. As we moved into the 18th century, science transformed its social structure. It evolved from early science, which was mostly driven by isolated tinkerers relying on sudden bursts of creativity in a workshop, into a deeply institutionalized enterprise. It transitioned into a sustained, state-supported endeavor that relied on the collective validation of a whole community of trained observers. The founding of groups like the Royal Society of London in 1660 actually birthed modern peer review. That's the exact same system we rely on today to know if a medical trial or a physics paper is actually trustworthy. Add in massive efforts towards standardization like Carl Linnaeus's plant taxonomy or shared units of measurement like the meter stick, and suddenly a scientist in Paris could communicate perfectly with a scientist in London. This institutional framework embedded empirical inquiry into stable organizations, effectively transforming science from a rich person's hobby into the vital, load-bearing pillar of our modern civilization. So, we've seen how humanity built this massive conceptual machine, turning magic into mechanics. But I want to leave you with one final provocative thought. If Descartes and Newton were right, if the universe operates strictly through determinism, where every single action is just the inevitable result of previous matter in motion, well, are we just gears inside the clock? Does human free will actually exist in a purely mechanical universe, or are we just watching the clock tick? It's a heavy question that the scientific revolution left us to wrestle with, and it's one that makes diving into the history of science so endlessly fascinating. Thank you so much for joining me for this explainer. Keep asking questions, and I'll see you next time.